Well, after your intro video, that pretty much jumps us right into like we're full speed, like moving ahead into this lesson. And the problems inside of your homework, they don't jump right into asking you for all of these characteristics that we're about to go over. They do break it down and focus on some basic pieces, like maybe ask you for the x-intercepts or ask you if it opens up or opens down. Some basic little things to start off. But I'm going to jump right into this, and then you just use this video for the part that you need. So this video will have essentially, let's just do 1 through 5, and then I'll have a separate video on how we actually will graph those inside of my math lab, because there's a little bit of a trick. I mean, it's nothing, but it's very, some people would not read the directions carefully and give you some trouble. So anywho, so we start off, and our first question we ask ourselves is our A value. Okay, so remember, in standard form, this is when we go back to the first page here of our notes. The first page is our A value comes first, our B value comes second, our C comes third. So here we are in standard form, ax squared plus bx plus c. So in standard form, in this case, to start us off, our A value is equal to 1 because the coefficient out in front is a 1. So therefore, that means that our A is greater than 0, which means that our graph will open up. And vice versa, if your A value was less than 0, if it was a negative number, then you would open down. Here, this is obviously a positive number, so you would open up. It doesn't matter whether it's a fraction or decimal or what it is. We're just looking at whether it's positive or negative. Whereas in the last, in Unit 3.1, that A value was a determinant of stretch and shrink. Here it's just opening up or opening down. Reflection over the x-axis. All right, so our next tool is going to be the vertex. So when we find the vertex, essentially what we're going to do is we're going to take this formula here that they provided, and here's really the formula for the vertex, which is rather confusing. So what I've done is I've just said, okay, well, if you want to find the vertex, the first thing you're going to do is to find the x portion of your vertex. You're going to take the little formula, negative b over 2a. All right, so we come across right here and we say, okay, well, negative b over 2a. Our b value is negative 6. So remember, our a is equal to 1, our b is equal to negative 6, and our c is equal to negative 7. So when I plug that into the equation, this becomes negative from the formula, negative 6 because our b value is negative 6, so it's 2 negatives, over 2 times 1. In that case there, that becomes positive 6 over 2, which is equal to 3. So at this point right now, our vertex is 3 comma, well, I'm not real sure. I need to find the other part out. So we take and we say, okay, well, that was part A. That was plug and find x. Now to find y, we take that x and plug it into our function. So y is equal to f of 3, which is equal to 3 squared minus 6 times 3 minus 7. And all I did was I took our x value of 3, we plugged it back into the original equation, we simplify that equation. That's going to be 9 minus 18 minus 7. And yes, I would have normally used a calculator. So let's just go from there so I don't make a mistake. Remember to go to your home screen. Second, quit. So I've got 9 minus 18 minus 7. It's going to be equal to negative 16. So my y portion is negative 16. That means my vertex occurs at 3 comma negative 16. So now we have our vertex. We know that our graph opens up. We have our vertex. And so if we wanted to, we could kind of start drawing like a rough sketch of this guy. And we could say, all right, well, let's see. We've got the xy axis. And like I said, I'm going to draw a rough sketch. This is not going to be drawn to scale whatsoever. So I go over 3 and down 16. So that is 3 negative 16. So that's where my vertex is. I know my graph is going to open up. So I know eventually my arrows are going to be pointing like this because of that first thing I found out about opening up. So now my job is to figure out where do I cross the x-axis and where do I cross the y-axis. So step number 3, if you want to find an x-intercept, and I would really recommend that you write this down each time you're doing it, so that way you kind of remind yourself of what you're saying. So like I would say to myself, oh, I want to find an x-intercept. That means I'm going to let y equal 0. So I go to my equation and I say 0 is equal to x squared minus 6x minus 7. Okay, so I mean at that point, like you'd have to factor, you'd use a quadratic formula, you know, and so forth. And the deal is that our technology would actually do this for us. So let's take a look at it. Okay, so we want to plug, and this is how we can see the graph too, but we need these values. We need to know how to find them. So we go and we go to y equals. Let's clear out what we had previously. And let's plug in our function. So we have x squared minus 6x minus 7. All right. Remember, if you're coming back at a later time, you might want to go zoom 6 to be able to get a fresh view of what this graph looks like. So remember, this is going 10 by 10. That's why we can't see the vertex, because the vertex is at negative 16. So that's be down here. Let's go to our table. Now, just to show you what you found when you plugged 3 in, when you plug 3 into this function, you got an output of negative 16. Well, there it is right there. So you really didn't even need to do this scratch work right here. You didn't even need to do that. You could have used your technology to find it. Now, remember what we were looking for and why we came here was because we want to know the x's. We want to know what x's we would plug in right here to make y equal 0. We'll start scanning around. Well, there's one. If x is equal to negative 1, y is equal to 0. If x is equal to positive 7, then y is equal to 0. So those are my x-intercepts. So my x-intercepts occur at negative 1 and positive 7. So as ordered pairs, those would be negative 1, 0, and positive 7, 0. All right, step number 4, let me get myself some more space. Oops. Step number 4 is to find the y-intercepts. So once again, I write down on my paper y-intercept, let x be equal to 0. So once again, I can plug this into my equation. I'm doing this for your sake, but I really, am not going to. So that would be 0 squared minus 6 times 0 minus 7. Now, you should be able to see this answer very quickly right here. But remember, we can go to the calculator and we can find it. We want to see what happens when x is equal to 0. Well, there it is. When x is equal to 0, y is equal to negative 7. That gives me my y-intercept at 0, negative 7. So now I have my y-intercept. I have my x-intercepts. I can then come back up here to my rough sketch, and I can go over and do my x-intercepts at negative 1, 0, positive 7, 0. My y-intercept is at 0, negative 7. And now I can go ahead and connect my dots and get the graph of the equation of my line, or my parabola. So that's the process that we're going to go through to be able to determine whether you're opening up or opening down, to find the vertex, to find the x-intercepts and y-intercepts. So it's really very I am teaching it very calculator based. You're plugging your equation into the calculator. You can go to your graph and kind of see what it should look like. I mean, I don't want you to eyeball these and be like, oh yeah, it happens right here. No, I want you to actually use your table and utilize your technology to be able to find those values. All right, so we'll have one more video, and that's just like how you graph this in my math lab. It'll be very quick. All right, so we'll wrap this up. Use this video for its different parts. So you got vertex, intercepts, axis of, oh, I forgot that one, and that was the axis of symmetry. Let's do that real quick. All right, so the reason I guess I forgot the axis of symmetry is because when you graph these inside of my math lab, they're not going to ask you to graph the axis of symmetry. They're going to ask you to graph the pieces I discussed. But just remember that the axis of symmetry would be that line passing like that. It's a vertical line passing through the vertex. And so if it passes through the vertex, that means its equation would be x equals 3. Remember, that's your AOS, your axis of symmetry. So you probably have a question or two inside the homework that asks you to identify the axis of symmetry, just knowing the characteristics and being able to determine where it's found.